Thank you. So we've been fortunate to see a great number of very cool demos over the past couple of days that illustrate the power of the open web platform, already usable in parts today and more coming soon. The power of this new platform also comes with new complexity, and our next speakers are going to talk to us a little bit about the challenges that this new complexity results in. They'll be talking a little bit about the current tools available to web apps developers, as well as some of the future standards that will make it possible to make these powerful web apps into safe web apps. Please welcome Brad Hill of PayPal, who's also co-chair of the Web Application Security Working Group at W3C, and Scott Stender, co-founder of iSEC Partners. They apparently act as hackers to help test out security, and they'll be talking about securing the next generation of web applications. Thank you.
Thank you. Thank you. So we're here to talk to you about the future of web application security. My name is Brad Hill.
My name is Scott Stender, and thank you for the intro.
So one of the things we want to talk about with the future of web app security is why everyone in this room has to care, why all of you designers, client-side people have a role to play in making the future of web apps a secure future, one that our users can find trustworthy and rely on. But to get you there, we're going to have to take you a little bit in a rewind and look at the history of web apps and how we've got to where we are today and what are the new challenges. Why is the future of web apps security so different? If we go back to 1994 and 1995 when the web was first invented, it was a pretty simple thing. It was a stateless protocol. It didn't look all that different from Finger or Gopher, if you are old enough to remember that. But the potential was really obvious, and people really quickly wanted to do things like banking and shopping online, add applications, and make the web into this rich experience right from the beginning. And with that came the realization that if we were going to be sending confidential information like cards, banking account numbers, passwords online, we needed a way to protect that information from prying eyes. And our original threat model of the web then was the attacker as an eavesdropper and impersonator trying to get your credit card information, trying to get your passwords. And we dealt with that by adding SSL, a secure sockets layer protocol, to provide encryption and integrity and authenticity to the web. And this was sort of the original threat model of the web that stuck around for a good long time. Is what do you have to do to secure your web? Well, add SSL. But we also found that the attacker could impersonate the client. The web was the first time with all these new applications that we had large amounts of rich application code developed at all these different places, exposed over standard ports and standard protocols on the internet. And it had to accept anonymous information coming in. And we were connecting the web to all these existing back-end systems in our enterprise. We were connecting it to databases, directory systems, huge amounts of code and other services in the enterprise, file systems. And this gave rise to a whole series of attacks, SQL injection, LDAP injection, all the injection attacks that you hear about, buffer overflows, things like that. This is a big problem. It's still the main problem we're dealing with today. The attacker's client threat model is a big deal. Luckily, there's a lot of information out there to help us address this kind of threat. And OWASP, the Open Web Application Security Project, is one of the best. And they publish every couple of years what they call their top 10 most common web application security flaws. And a lot of good advice on how to fix those. It's one of the first places I've always sent people. And if we look at their top 10 for 2010, we see that 8 of their 10 items all fall under those first two threat models we were talking about. The attacker is impersonator, the attacker is client. They're all things that are dealing with the server side of web application security. There's only 2 where the attacks are a little different, where the attacks are targeting the web application client. And we'll look at those real quick here. These are a threat model where the attacker is the server. The attacker is sending data to the client. And this got interesting when we added JavaScript to the browser in 1995, when webs went from being pages to being little applications to being active content. And that was interesting now because we wanted to make sure that the bad guys can't take advantage of that active code to read your bank account balance, to read your cookies and your credentials from other secure sites. So the measure that was invented to prevent that is called the same origin policy, which says every origin, when content comes from a scheme, host, and port, is isolated, and you can't read information from anywhere else. Now, the nature of the web is you have to be able to include images, include style sheets, things like that from other places. You have to be able to send requests, post across domains. But we have this read barrier, the same origin policy that's supposed to keep us safe. And again, this has worked for a long time. This dates back to 1995, and it's still a fundament of web security today. Some ways to get around the same origin policy, attacks that have come up. Cross-site request forgery is an interesting one. This is where I go and see the dancing pigs at some random website. My friend emails me this link, and I want to see the dancing pigs. And what the bad guy sends is an iframe that has a URL that says, transfer some money, $1 million to Mallory. And my browser is going to go fetch that. And if my bank isn't careful about how it processes my credentials, my browser automatically attaches that cookie, and I can have the attacker's intent taint the request that my browser makes with my ambient authority. We can solve by putting some additional secrets that the server sends to the client only in legitimate requests that the attacker can't guess. But cross-site scripting is the real client-side attack to worry about. This is the one that, if you ever worked in web security, this is the one that just keeps hammering you over and over again. It's the never-ending thorn in your side. And really, it's code injection. That's the way we want to think about it. Cross-site scripting is a moniker that arose out of this first pattern where it was identified, where if I was sending content to a web application, if I was filling in a form with my name, instead of writing Brad, I wrote script alert. If the server just sent that back to me in the resulting display page and didn't encode it, that could actually affect the markup of the page. I could inject nodes into the DOM. I could add script. And if that content was sent to me unwillingly by an attacker, site A is now able to script in the context of site B, hence cross-site scripting. But really, it's more complicated than that. And why we see it's really more like code injection because of things like stored cross-site scripting, where if I have a blog or a forum where users are allowed to post comments and I can see content contributed by other users, if those users are able to submit active content that changes the markup and layout of the page and is allowed to get active script execution, they can put in data that gets stored in a database, and later on when I come to view it, it gets me, this may be cross-user scripting, but still retains the moniker of cross-site scripting or XSS. Luckily, all these three things we've seen still are able to be fixed at the server side. All those data flows still transited our main origin server, and the same origin policy means that we can trust the code that came to our client and is executing in the context of our origin. So of our OWASP top 10, we can fix them all on the server side. And this has been the conventional wisdom of web security to this point. Don't trust the client. The client might be the attacker. Always defend the server, defend the assets of the server, and defend at the server side. If you're doing validation, don't validate on the client just for easier experience. Revalidate everything again when it comes to the server. And this has led to a model where we've gotten very sophisticated about those defenses. We've put a lot of investment in there. We've done firewalls. We've had web application firewalls. We have input filtering for all these different types of systems and grammars and languages that are in our applications today. We've encrypted our databases and credit cards there. We've added cross-site request forgery tokens and output encoding. We do static analysis of our website code. We have automated scanners. We have a whole software development lifecycle that's focused on security, code inspection, checklists. We've gotten really good at making this big investment on the server side. And that's great because it means the creative user experience types that are making all these awesome demos we've seen today can go do their thing, and us killjoy security nerds can be locked in the server room to work on fixing things and making it secure. But you can see I've labeled this slide as Web Security 1.0, and I think we're all aware here that we've moved a little bit beyond Web Security 1.0, where Web 2.0 has arrived quite a while ago.
You know we're security guys because we're talking about Web 2.0 like it's something new and exciting, right? So, Web 2.0, AJAX, comes along and empowers the client. So all that processing that we used to put on the server side and serve down the client in one big slate of UI now starts getting pushed down towards the client. And first instance of this is an Outlook Web Access for Exchange 2000. That's the little picture you see on the left there. If you read the little article that comes out that's associated with the Exchange 2000 product on Microsoft's TechNet website, you'll see this description of how great this is. And if you look into it, it's like all the the wonders of AJAX are described in this really boring old corporate language for this one little website. But who knew that in 2000 this little website would become the first example of this new architecture that we all enjoy and take for granted for now. The big thing for me that explained the wonders of AJAX was Google Maps, which you see on the right. That one just was the jaw-dropping experience when I clicked and dragged on the map and I saw out of nowhere this little picture come up and fill in. How amazing, how awesome. And that wonder is achieved by taking that processing server side, pushing it down the client side. Now, when we as security engineers think about that, we're not just thinking about we're pushing UI down. Of course, that little picture got down there somewhat magically, and it has a great user experience, a great UI, but that for us means we're not just pushing around mobile UI, we're pushing down mobile code, complexity, intelligence, Turing machines, all down there. So with that additional capability in the client comes additional potential for attackers. So Brad talked about two variants of the cross-site scripting security flaw a moment ago. With this new rich client experience, we see a third variant, the DOM-based cross-site scripting. So we have our client wants to interact with its legitimate server, but happens once again to go to dancing pigs at the badguy.com website. And badguy.com sends information back to the client that gets interpreted by the DOM that's associated with the legitimate, say, bank web server. And that content finds its way into an iframe, HPS bank.com, app.js, hashtag alert XSS. Now, when the client interprets that attacker-polluted URL, it's going to send only the app.js up to the server. It doesn't need to send that little hashtag alert XSS because that's not part of the request, right? So that goes on up to the website. Website says app.js, that's a fantastic place to go. I'm going to send you back a little bit of information along those lines. But that alert XSS, even though the server never saw it, is lurking somewhere latent in the DOM. It's coming, don't worry. So let's say that DOM, what it does is it sees this little bit of attacker-polluted information. Of course, it expects that iframe is going to drive a request, but then it goes back and looks at that and does a little parse. It splits that bit of text, it finds the first element of the split array, and then it does an eval on that. What we now have, what might be unexpected to the server-side developer who's pushing down not only the information or the code on the server side that creates all these pages, but also is pushing down the JavaScript that runs somewhat independently on the client. What they don't expect is just how that split happens, where the attacker supplied data is, and sure enough, end-to-end, we once again get arbitrary cross-site scripting attacks based off of arbitrary code that can execute in that DOM. Now, the interesting thing about this flaw, as opposed to the reflected cross-site scripting and persistent cross-site scripting attacks that Brad already mentioned, is that notice the server never sees the actual nasty script. It sees get app.js. It doesn't see get app.js pound alert XSS. And that is the problem. The server can't see, can't validate, can't fix this problem. It's a fundamentally client-side problem, and that's because, once again, we pushed all that logic down to the client. So it might seem like a contrived example, and indeed it is. We made this up based off of sanitized examples of what we've seen as testers trying to find these flaws. But of course, every instance of such a flaw is contrived. If it was a easily described general purpose flaw, we'd fix it in an easily described general purpose way. What we're always looking for are the little exceptions to what the developer intended, because of course that's where the security flaws lie. And indeed, a company, Minded Security, has done some surveys based on some of their tools of various websites, and found that 56% of websites are susceptible to this DOM-based cross-site scripting attack. And this is the source of real vulnerabilities against Twitter, Omniture, a very scary one there, and more. So if you watch the security list, you see plenty of these attacks coming out. And indeed, I mentioned attacker-polluted content coming from somewhere. It really can come from anywhere. There's a bunch of different locations that are common to look for inside the DOM, but it really is. We're making general-purpose, generally computable code. Data can come from anywhere, and so that's where we want to look and see where attackers can get data in and make sure it's validated properly. And indeed, the client is the right place to look for it. Now, I've talked about how even in the web case, the server doesn't always see the data that needs to be validated. And that if they're dropping the pound alert XSS, the server doesn't have a chance. But indeed, the platform, which we assume still is client and server, is getting pushed out to many scenarios that don't even involve a server. And here are 4 places I'm not picking on, but just are good examples of where web platform, HTML, JavaScript, everything else is living that has nothing to do with a server. You know, Skype, many desktop applications just host a little browser control that render the full HTML environment, and there's no server that's serving up those web pages. The app is creating them based off of input from whatever source. You know, say, for example, your Skype buddies. If you are a mobile app developer, I don't have to tell you that the greatest way to make cross-platform, content-driven applications is to drive all that content via sort of web feed and then just write the very thin Chrome around that data so you can just make that Chrome quick and easy on whatever platforms you want to support, and your rich experience is going to be delivered by these great new web technologies. So you see this a lot in iOS, Android, the other apps, or the other mobile apps. And then finally, we mentioned a little while ago that Microsoft is buying into this platform in a big way with Win8, announced the Build conference. Not only will you be able to write in C and C++ for Win32 and C#, VB for .NET, now you can write in JavaScript and HTML5 for WinRT. So again, big web experience. There's no server, there's no web server to be found. So what does a cross-site scripting attack look like if there is no site? Kind of like what happens when one hand claps. Well, it sounds a lot like this. So Skype, and I don't mean to pick on them, this is all over the place. It's just a great referenced flaw that was found by a security researcher recently. They found that the Skype window, which shows your bold tags and smiley faces and other rich experience things, was indeed a web control. And you could get arbitrary script to execute in your Skype Buddies window on the Mac version of Skype. And indeed here, instead of doing a little alert to prove the concept of, hello Brad, little pop-up, they did an alert of the password file on that machine. So when you have a cross-site scripting attack happen inside of a web server type of environment, that means you can mess with that web server. When you have a cross-site scripting attack happen without a site, say in the local systems context, then you have access to whatever that system gives to the DOM. In this case, the full file system. In Windows case, all COM objects and all manner of other things. So what does the sound of cross-site scripting without a site? It sounds a lot like full client compromise or full server compromise, whoever's interpreting that. Now, we have mobile code all over the place. What about data? We saw Google Maps a moment ago. And wouldn't it be great if I wanted to use map data and have a rich map experience, but I didn't want to have to go through everything that Google went through? Acquiring the map data, making it beautiful and browsable and searchable and have addresses in there. That's a lot of work that a smart company and a lot of smart people at that smart company had to accomplish. And all I want to do is make a restaurant review site. I just want to be able to point out, here is a little window where that map can be found and you can browse around there. Wouldn't it be great if we could have data that is associated with, say, maps.google.com be integrated with scotsrestaurantreviews.com? Can't we reuse that service? The answer, of course, is no. There's no way, right? We talked about this a moment ago. We have bank.com, we have evil.com. We know what happens when these two servers can drive my one experience. Evil.com gets my cookies. Evil.com can inject code and drive my UI. We have the same origin policy that's supposed to keep these servers aside, right? So none of us has ever seen a Maps mashup, right? Anybody, designer, find a way? Anybody seen the Google Maps API? How could this work if the whole security architecture of the client-side mobile code experience is based off of the servers shall not meet? Well, first-generation mashups are based on hacking the same origin policy. Now, I don't mean hacking in the way that people think of evil security hackers coming after our stuff. I mean in the brilliant, we find what we have and we try to make stuff work even when it's not supposed to. Same origin policy says these things shouldn't happen, and that's a principle that has been put out there. But there are clever uses of a script tag, image tag, iframe tag, all these different tags that will allow a HTML file served by one server to reference content on other servers. I want to bring in iframe, and from the user's experience, there I am. I'm looking at a different website inside of the website that I went to. If I'm using image tags, here's an image that came from somewhere else. If I'm using script, I can pull in script from anywhere. What happens when I do that? Does that script run under the context of the source server from where I downloaded that script? No, it runs in the DOM of my server. So that is something that allows full compromise of my DOM, right? I'm running real code. Now, JSONP is a fantastic example of a mature technology built on such a clever hack. If I want to get real, full, interactive data from another location, I can just use this thing that all of us have probably used at some point to pull in that code, get rich client experience, and not have to worry about this same origin policy thing that those annoying security guys always talk about. But, we're all for rich experiences. But on the other side of things, we think of as JSONP as a great way of inviting arbitrary code execution, which is the end-all, be-all security flaw, if we think about it that way. Everything we want to do as an attacker is run code that developer doesn't want us to run. And when we, as a web developer, invite script to run in our DOM, we're inviting very specifically client code or arbitrary code execution, but at least we know where it's coming from. It's coming from jQuery or Google or whatever else. But you are still inviting that. Another, maybe more snarky way, is we say we put all of our security in the hands of that script source. We sure hope that they're nice about what they give us, but we know that if they were to give us something malicious, that they could drive our online banking experience. They could make nasty reviews from Scott's Restaurant Review. Now, of course, as developers, we might think of it another way. Sourcing script gives that servers, administrators, and developers check-in rights to our client-side code. When we source that script can blow away our DOM, recreate it from scratch, put whatever content they want there, put in whatever code they want there. When we do that little use JSONP, use script source equals whatever on the web, we're essentially saying, we trust you, we like you, you now get check-in privileges. And think about just how widely you'd give that out if somebody asked it in a more direct way. But they are trustworthy. I mean, we make the explicit decision to trust jQuery to pull down the code from there. But even trustworthy companies are compromised. If you have a passing interest in security, you might have seen a rather explosive fireworks-oriented year that passed us. Everything from security consultancies like one I work at, not the one I work at, double emphasize, not the one I work at, but security consultancies getting compromised, major media companies getting compromised, and this is on top of the last decade of everything from financial institutions to major media sites being compromised. Even trustworthy companies that we would like to believe in their best intentions are compromised and can then start sending us nasty code. Even trustworthy companies enjoy your customers and your data. If we're pulling in data, somebody's paying that bandwidth charge for us being able to pull down all their data. Maybe they get something out of it, and that's something you want to think about as well. What control am I giving them? What information am I giving them about myself and my users? And that's the one question. It's not saying that you can't ever do it. You don't want to be the security industry of no. But think about it in that risk sort of way. Am I giving away information that my users would not like me to give away? Am I giving away information about my company that I'd rather not give away? So we've talked about Mashups 1.0, how we use clever hacks to get around the same origin policies so that we can make these rich experiences, which I must say are totally awesome and cool. Brad's going to talk about how the technologies that are coming up that allow us to do so in a more structured fashion that allows us to make more security architecture around it.
Thanks. So we've seen all these kind of hacky ways to accomplish mashups via code injection. So we really want ways to do this with permission. We want ways to have richer experiences on the client side and bring together code and data from other places in a safer, more structured way. And HTML5 APIs provide a lot of opportunities for us to do this as developers. Cross-origin resource sharing and XML HTTP request level 2 are a great example of this that probably a lot of people have used. It's supported in most browsers today. This lets a server give a client, by permission, lets it relax the same origin restriction. So you're allowed to read this if you are coming from this origin, or if you give me the user's credentials. So you can share data anonymously. You can share data based on a specific origin or based on a specific origin and user's credentials. And you can share richer types of data than just XML or JSON. You can have files, form data, blobs. Very powerful API in very wide use today. And this is a big improvement over the JSONP type request. We heard a little bit this morning that WebSockets is on the way, which is an even richer model here than cores, where you also have cross-origin communication, but it's bidirectional. It's not just HTTP, it's full TCP/IP communication. Client sends a verified origin, the server can decide what to do with it. These are really powerful tools as developers. As security people, we find them a little more challenging than some of the plugin-based approaches that they're replacing. It's not as easy to go and just look at the server-side code and say, oh, here's a cross-domain.xml policy file that tells me what are all of the origins that are allowed to connect to my site. I have to enumerate that in my code somewhere. It's based on every single individual HTTP resource and whether the credentials are coming and what origin it comes through. I can't see this until I make the request. So it makes auditing a little more challenging, but it's still a big step forward. We have other technologies like postMessage that are taking the game even farther. So cores, XHR, WebSockets let you communicate from one client to multiple servers. Now, postMessage lets you communicate between multiple instances of web applications running in the same browser. So now the principal has gone from being a server that's under some administrative control to some other chunk of code running in your browser. You can say it has an origin. You can say only send this to this origin. But what if that origin includes data and code from 3 different sites itself? What if it's a mashup? What does that mean about its identity? And those message ports can be passed around. So we're introducing, again, powerful capabilities, interesting ideas, but it's changing what the security model means in really big ways. And then we go another step further to WebRTC, which is still in development, but this is real-time communication for taking your streaming video you're watching on your big screen TV onto your tablet as you walk up the stairs or on your phone as you walk out the door and keeping it seamless, moving data streams between web application client-side code instances on different browsing contexts even, with real-time performance constraints, with really complicated media files and different codecs, lots of data moving at high speeds, high complexity between web security principles that we don't know a lot about, who's running them, what code do they contain, how much can we trust them. So we've added a lot of cool possibilities here. We've added more structured, permission-oriented, explicit interfaces compared to the traditional Web 2.0 original mashup approaches. But we also increased the graph complexity of where data is coming from and what paths data is arriving at our client from quite a bit, to multiple servers, to multiple applications in the same browser. We also have web storage there, which I didn't talk about, but web storage is adding much richer client-side storage capabilities long term. If that gets polluted, that could also be a source of attacker-controlled data. If you're not careful about it, that can last a very long time. So we have this rich model here that's not at all reflected in our picture of where we've made all of our investments in security so far. Right? We already saw this investment can't help us protect against DOM-based cross-site scripting. But our client-side picture now is a lot more complicated. We have rich application code, libraries running to tens of thousands of lines of code that we're pulling in. We have local, state, and storage. We have requests going to other servers in the cloud that we don't control over a variety of protocols. We have properties and data that's getting into our DOM and influencing how our application state runs that can come from those servers even if they're not making requests. We have other rich applications that have all of the same origin capabilities back to their originating hosts with their own data stores that now can communicate real time with our application instances. And we have plugins still that also can manipulate the DOM, have their own state, have their own impact on things. So there's this huge client-side set of complexity that we're all dealing with, we're using to make the awesome web experiences of today and tomorrow. But we haven't put any of our security investment on that side. If you've ever done a threat modeling exercise, you notice there's a lot of data flows there that don't have any mitigations attached to them. So assets and attack surface are moving to the client, but we're still only defending at the server, and the server doesn't see all those data flows. It may not see a majority of the data that happens in a modern web application. This isn't to say that the servers are all right and we can stop working there and we just focus all our efforts on the client. Unfortunately, servers are still broken. We're still seeing compromises. It's still a big challenge to get that security right, even with all the best practices. But the future of web application security, the things we need to start thinking about we haven't been working on yet, and the reason why everyone in this room needs to care and be involved is that that future is in the client. It's about defending inside the client and applying this knowledge that we've developed on the server side to these new data flows and these new technologies in the client side.
So what next? Call to action. We have a beginning of one there, but more details, please. So the big thing that I find very difficult about analyzing web applications that have taken on this new mashup, Web 2.0 rich experience is testing it. We have, as a security industry, been stressed by the abilities, or our ability to test Web 1.0 with who cares about the client, it's just doing simple requests. There's so many different types of attacks, so many different requests on a website. So much time is required to go and identify which tester is successfully finding flaws that you really have this very difficult combinatorial explosion. Makes it so that we still have compromises, high-profile compromises against well-funded companies today, and that is testament to the fact that we are still learning how to test and verify that everything is safe in a Web 1.0 world. Now, security analysts. We have to manage the explosion that comes from dealing with all of the state and context that comes from the DOM, which is quite literally infinite in what we can put in there. So take all the difficulty we already have, multiply by infinity, there's the problem that we're thinking about how to address in the next 10 years. And I'll say that test tools and even developer tools are not where they should be for being able to give the sort of insight into the behavior of the application so we can identify what it is that we need to test and then actually start launching the tests that we can use to verify that something is safe or not. And so if I had to kind of paint a rather large and unfriendly brush on the state of tools today, it'd be like my friend from the Dos Equis commercials. Don't always test my code, friends, but when I do it in production. Of course, the security friends among us would say, thank you. The security people here would say, stay vulnerable, my friends. The problem is that, think of the word mash up. We take all this stuff that is, runtime from all these different, sources that we don't control. We don't understand the space of what they can possibly do. And we mash them together and mix them up inside of our client DOM. We get this great experience that is required and wonderful, except for how do you verify that space of possibility and identify only the specific things that we want to work are working safely and that everything else we can kind of go away with and say, we don't have to test that because it's impossible. With so much being possible, we can't but test in anything except for production because that's the only time we get the state that's testable. And that means that we have a constantly moving target with infinite potential test targets. And so we're always going to be poking and finding our way through what we expect is functional and never getting to the bottom of, we know it's safe. What can we do? First off, start thinking about how we avoid the game over technologies. And I mentioned JSONP. I'm picking on that only because it's very familiar and it's one of these more developed, clever hacks. But that and other things that use methods that just violate the same origin policy by design, by necessity, are technologies that we should start thinking about how can we move beyond them. And Brad talked about the technologies that take that place. If we have JSONP be very unstructured and very with infinite possibilities of what can it introduce to our DOM, maybe we can think about something that does less, meets our functional requirements, but is more predictable and structured. The other thing is plain text HTTP. We all, any security person has probably said the words SSL or TLS to you and probably said, please turn it on and please architect your web application so that it uses it. The one reason why we say that is not just because we worry about attackers in coffee shops, but because that is where we get the basic building blocks of web security. If we know who's giving us that content and we know it in a trustworthy manner, then we can start doing interesting things. We can start assigning meaningful security assertions to how you're building your web app. And so starting with try to avoid those game over technologies. If you're using HTTP, you can't really vouch for much. If you're using JSONP or other things that completely compromise your DOM, if there's the other side of that as an attacker, then we can't do much for you. So what do we need in order to move away from there? Well, we need to have mobile code that's designed to be securable. We need it to be compartmentalized so we can say, okay, we know we can work on that. We can work on that. We don't have to worry about that if we're working on this. We need to be decoupled. We can think about things in a explicit interface-oriented manner because then we can test that interface rather than the infinite possibilities of what can happen inside the DOM. And if you are a developer here, you might think of the first insights you had with test-driven design, where when you said, oh, if I can think about making it testable, then all of a sudden I get all these other attributes like explicit interfaces and like composability and things like that. So those are the beginnings of how we think you can architect web applications to be secure for the next 10 years. Brad has some more specific details.
Yeah, so what are the specific things? There are some things we can start doing today right now to achieve these goals of compartmentalized, isolated, testable, securable applications. There are some things that we can do right now to prepare for the future. And then we have some technologies coming, some available now, some in the near future that are going to help us out, change the game on client-side security, make some of these things possible in security that we've always neglected in the past. So we talked about the HTML5 mashup APIs, using these interfaces that are about data rather than code moving and being able to do validation there. Scott mentioned about authenticating origin, using HTTPS everywhere, using HTTP strict transport security, which is a server header you can send to a client and say, Hey, I only talk secure. I only talk over HTTPS. Don't ever try and contact me over HTTP again, even if someone else tells you later. They're not allowed to say that. That's the bad guy, so don't listen to them. This is a technology PayPal's been pioneering deployment of. We'd like to see it a lot more places. The richness of web applications today means you can't just count on, well, if my user is at the coffee shop and gets compromised, he'll close his browser and start it up again and it'll go away. Rich client-side state, long-lasting applications, web applications that stay open in browsers for months mean that recovering from those kind of compromises can be very difficult or impossible. You need to make sure you're protecting people at every step across all their channels. Secure design, again, you don't have a hope of doing this unless you start thinking about your design in a way to make it secureable from the beginning, compartmentalizing and sandboxing content from different origins. And we'll talk about a little of that, methods for that, and then look at some of the tools for client-side testing. So from compartmentalization, we have a number of tools at our disposal. HTTP-only cookies have been around for a long time, 5, 6, 7 years. This is sort of an unrecognized pioneer in client-side security technologies. It's the first policy about isolation in the DOM that a server and a client enforce cooperatively. The server says, hey, keep the credential state isolated from the DOM. Don't let the DOM read this information directly. It can be part of the information that gets sent, but I can't modify it, I can't read it. This isn't enough. Obviously, we've seen cross-site scripting means that the attacker can drive your application and make use of those credentials, but it's a good start. Minimizing foreign origins. We talked about how script source, JSONP are allowing other sites to control your application. So think about, do you really need to source that library directly from Google, from jQuery, from Microsoft? Can you, load it in from your own site, from your own origin? Can you keep control of what that code is and know what it's doing and know where it's coming from? We've seen compromises of CA authorities recently. There was a malicious cert issued for Google.com. Think of what that would have been like if it had been for GoogleAnalytics.com. Think how wide that compromise could have gone, because people are pulling in those kind of content, those web widgets from into thousands and millions of sites. And on your own content, create unique origins so that you can apply this isolation within your own applications. If you're example.com and you have content contributed by users that might be dangerous, put it at example-sandbox.com so that a malicious file that you can force a user to browse to directly doesn't have access through its code to reach into the DOM of your running application. If you're making brochureware or marketingware that you don't want to test for security because you don't have the budget to, it's not important, it's just a marketing brochure, put it on its own host, example-marketing.com. You don't want a cross-site scripting vulnerability or a code injection problem with that brochure to be able to compromise your mainline web application. And keep in mind that script can always make its origins less specific. So it can go, if you said marketing.example.com, that script injection can lower its domain to example.com and still attack you. So you have to use some of these sandbox technologies, create some new domain names, pay for some new SSL certificates. It's really not that much compared to what's at risk. And we have some new technologies coming in HTML5 that can help us out with this kind of isolation of origins. If we have a blog right now and we allow user comments, Mallory is able to find a bypass on our filter. If we throw that in a seamless iframe sandbox, the user experience is exactly the same, but that user contributed content has now been put in a null origin container so that script can't talk to our mainline application. And we can use the same technology to sandbox some of our legacy problems like JSONP interfaces. They're not going away, but what we can do is put that code in a sandbox and create a postMessage channel to that sandbox so that we've gone from a code injection-based pattern to a well-defined data passing interface. We can start doing validation on the client side. In fact, this is a better place to do validation than on the server side for many of these cases because you're at the layer, you're in the DOM, you can see what the parsed result is. Whereas the server kind of has to guess. It doesn't know all the intricacies of the browser engine and what is going to be rendered as markup and what isn't. The server side's or the client side's a great place to do that because you're at the layer where the attack is targeting. We have a lot of experience in doing this on the server side. There are some good libraries starting to be developed on the client side to do this. Here's one from jQuery. And we have some good starts on tooling for testing our applications for these DOM-based XSS. Dominator is one by Stefano DePaula and Minded Security. It's available for free. It's a great tool. DOM Snitch is another one by Radislav Vasilev. Google. It's a passive tool that identifies a variety of different risks, not just DOM XSS in the DOM. And there are some commercial tools from IBM and Blue Infy on the same thing. Don't expect these to be as polished as your Covarities, as your Fortifies, as your existing analysis tools for server-side code. It's a lot harder to do in the dynamic environment of JavaScript, and these tools are much less mature. But if we start using them, if we start contributing bugs and contributing features, we can help drive that ecosystem forward so that we have that tool base to rely on as we work to build these more complicated applications. And we can use things like WebDriver and Selenium for testing in the client. These are some of the things Philippe talked about yesterday for testing our standards. We can also use these to start building good unit test frameworks for our applications, including security testing. So making and demanding that better tooling is a good part of bringing the future forward. The content security policy is going to be another key feature here. Talk about that in a second. But also, along this line, tell your browser vendors, tell your API vendors that security matters to you, that you care about them implementing these features in the browser, that you care about them being available on all platforms. If you're providing APIs, provide the safe APIs alongside your existing JSONP APIs. Demand that your providers give you HTTPS endpoints and that they give you cores and XHR2 interfaces instead of just JSONP. You have to communicate and make demand for this in the market. We're the influencers, we're the innovators here, we're building the killer apps. We have a voice in making this possible. And content security policy is one of these things that I'm most excited about. It's something that the working group I'm co-chairing is bringing forward. It's based on years of really cool, innovative work and pioneering work by people at Mozilla and Google, Brandon Stern, Adam Barth, a lot of others there. And it's now on the W3C recommendation track. We're scheduled to publish a working draft next week. But it's already available in betas on Firefox and Chrome. And what this lets you do is send a header or a meta tag that gives you a least privileged environment for your code in the browser. It says no inline script, no code from strings, put some big restrictions on how data can be created dynamically from data URIs so that you get the code you expected and nothing else. Even if there is an injection, there's very little it can do. You can have that environment and sort of reduce the impact of the bugs you missed. We're always going to miss bugs. The way we've been succeeding in traditional application security is by reducing the impact of the bugs we miss. So this is a great technology for that. We have other ways to reduce and whitelist the origins for images, media, plugins, et cetera. And what you can do now as you're building these applications is think about keeping your code structured so that you can apply this when you're ready to. Don't use inline script everywhere. Keep a good separation between your markup and your layout and your script. Attached to the DOM with libraries rather than putting all of your code in line. So that's going to help you be ready for CSS when it comes on. And we still have a number of challenges remaining. Clickjacking and UI redressing, something we haven't talked about a lot. It's where content can frame other content and trick the user into sending clicks into it. This is a big problem for the kind of mashup-oriented, rich UI that we expect in the web for scenarios like and pay and friend. It seems like it's kind of a trivial attack, and for certain cases, you can do back-end analytics and fraud detection and reverse fraudulent payment. But it's very hard to claw back your social graph if someone friend-jacked you. That information's gone. You can't get it back. We have a technology, XFrame options, that lets you say, I don't want to be framed. But really, that's kind of breaking the web to save it. We want to be able to do this safely, to allow rich mashups, and still have a safe experience for users. So this is another thing that we're working on in the Web App Security Working Group. It's a really hard problem, I'll tell you that. We don't have a clear, obvious solution for it yet, and so we're still soliciting input. If you have cool ideas on this that you want to contribute to the standardization process, find me, join the mailing list, be a part of the conversation. And unfortunately, the DOM is still a mess, right? We all know this. Anyone who's tried to write any DOM applications knows that there are huge differences from browser to browser and lots of infuriating things that don't work. If you think that's frustrating trying to make things happen, think how frustrating it is trying to make things not happen. Think about all of the possibilities and extra things when you're trying to reason about what can this application do that I'm not expecting? What are all of the weird things that are hidden from me that aren't exposed? What are all the weird tricks that a bad guy can use and knows about that I don't? That's really hard. This hinders our tool market. This hinders our ability to understand our attack surfaces. And it really stops the ability to make cross-platform testing tools and simulators. There's amazing work going on. I would especially encourage you all to go look at the research that Mario Heidrich and Gareth Hayes are doing right now in stopping XSS. They're building really cool stuff in client-side sandboxing of the DOM to do role-based access controls, to do validation, whole server-side or client-side security frameworks that are way more effective than anything we can do on the server side. but they're constantly being foiled by all these bugs in the DOM. So maybe one of the things we need to start thinking about going forward is the need for a strict DOM that at least you can opt into as an application developer. Now, at the W3C, we're very good at giving the standard. We, in conjunction with the browser makers, are getting better at giving you the whole standard. But the last part, and nothing but the standard, is still a future frontier for us, right? But that is the essence of security, that an application does everything it's supposed to and nothing else. And so getting there is going to be a big part of reaching a level of assurance about our applications that we don't have yet today. So thank you very much. Those are our names, and these are some of the people that we follow on Twitter and are blogging and are very active right now. There's many more people doing great work in the web app security world right now, but these are some of the most active who you can get some cool stuff from on a daily basis right now. Thanks very much. I think we have a little bit of time for questions. Everyone wants to have lunch. Oh, we have one here.
Hi, Manus Forney, Digital Bazaar. We talk a lot about security, and we tell people to put, their sites up on HTTPS, and that's going to protect them, right? But there's this thing that's been happening recently, I guess over the last 5 years, where we have more and more security certificate authorities out there, giving people more and more certificates, and some certificate authorities have been compromised and have given people certificates that are non-trustworthy. And now there's, we're concerned that China can create a certificate for someone that says, yes, you are actually talking to the U.S. government, or you are actually talking to a trusted site. What do you think the solution for this is, right? So we have a bunch of certificate authorities out there. Our security model is that we trust all of them, but the reality is that there are a few of them that we absolutely cannot trust. How do we transition to a more secure platform?
I share your concerns, and one of the other hats I wear in the Internet Standards, the governance group at PayPal, is working with the what we call the CA problem, the trust problem. But that's a great topic for a 2-hour panel discussion with 5 other experts in the room, and maybe a working group and creating a new governance structure for secure names on the internet. It's really a big issue, and it's not something we're just going to solve with a technology switch. There's a lot of people proposing new technologies, from Dane to convergence, whatever. It's a complex problem with a lot of assets. We need policy-based solutions. We need ongoing governance models to collect all of the concerns and address all the issues of the problem. And it's not something I can address. I'm already a minute and a half over, so come talk to me, get a business card if you're interested in helping fix that issue. We're working on it, but it's orthogonal to this work.
But the recommendation to start off with using HTTPS will hold. I am 99% sure with any solutions that come to that trust problem, they're going to hook into HTTPS, fingers crossed. And so it's still a good idea, a required idea.
All right, we got to wrap it up.
Right.
Thank you. Enjoy
Thank
your
you
lunch.
all.